to kick off our next series of lightning talks, I would like to introduce Stephen M. Kivuti, who will be presenting their case on assessing energy budget disruptions and the implications for hydrology, climate, and engineering practices using Mureithi and series satellite instruments. The floor is yours, Stephen.
Okay, so we are going to our project. We assess the energy budget disruptions and the implications for hydrology, climate, and engineering practices in the Nzoia River Basin using Mureithi and satellite instruments. We can move to the next slide. Okay, so basically what this slide talks about is that this project was used to assess the energy budgets for Nzoia Basin for many purposes, including making decisions in the national level and the local level in terms of land use, how to manage our infrastructure, and other purposes as necessary. So we have the instruments that we use described there, and the data sets that were used, which were Ceres and Mureithi. So with that, I think we can move to the next slide. Okay, so this slide, what it basically says is that for a stable energy budget, the figures on the right, those are the approximate percentages. If you look below and if you look above, those are values. So for a steady energy budget, it's supposed to remain around these levels with the amount of solar radiation coming into the atmosphere equals to the amount of solar radiation leaving, as you can observe in the graphs listed above. So with that, I think we can move to the next slide. So this is the basin we used. We have provided all the information, but what you need to know for the purposes of this project was that the basin is located near the equator, and there are 4 zones. We have a lowland zone, transition zone, a plateau zone, and a highland zone. And we should also note that the degradation was observed as we were analyzing the study. So move to the next slide. Okay, so these are the parameters collected from power. We can see we have atmosphere shortwave downward irradiance, all sky surface shortwave downward irradiance, all sky surface shortwave upward irradiance, all sky surface albedo, all sky surface long wave downward irradiance, and all sky surface long irradiance. So a special note, the data started from 1984 so to 2020. That was what we used, and all the values were collected by the Power Data Access Viewer, apart from the shortwave sky surface long wave upward irradiance and top of atmosphere shortwave downward irradiance. These 3 had to be collected via API because they are not available in the Power Data Access Viewer. So we can move to the next slide. So these are basic characteristics. There's a lot of information there, but what you need to derive from this is that you see the amount of solar radiation coming into the atmosphere match the solar cycles as they have been established. You can see we've provided their start years, peak year, end year, and how they are used for the project. Another thing we have to know is that their monthly values coincided with its summer and winter solstice and the equinoxes. So in a nutshell, the basin receives an average monthly solar irradiance of about 415.65 watts per meter squared. That's what this slide is trying to describe in a nutshell. So we can move to the next one. So we have a summary of results. It was found that there was a relatively constant shortwave radiation into the atmosphere. It was about, the range was about 0. A bunch of zeros and a 9 of the end, meaning that any changes that were to occur in the values inside had to do with the human activities, and maybe it had nothing to do with the amount of radiation that was coming to the atmosphere. So with that in mind, we see that the annual shortwave downward irradiance showed wide fluctuations. These were attributed to a change in the weather, that is the cloud cover. We did correlation and noted that that was making the difference. So, okay, the results basically showed that, okay, so now we have a commentary on land degradation. As we can see, the basin from 2015 and 2020, after delineation and supervised classification, you can, if you look carefully, you can see how much degradation occurred in the basin, and that was reflected in the data. Although we can also, so for the basin, we have a lot of degradation, which has obviously had something to do with the changes in the energy budget for the basin, and consequently has affected climate change. We can move to the next slide. So how are we using power data products? So as I said, we have, in this case, we used it to analyze energy budget dynamics, the shortwave and longwave radiations, and the meteorological variable in Nzoia River Basin. This is used to make decisions, as I said, in the national and local level about issues like what areas to conserve, how much reforestation do we need to do to make sure that the climate is not affected in the basin, and issues like that. So can move to the next slide. I think. So what data products have been instrumental in providing the necessary information and measurements are required for assessing the energy budget of the Nzoia River Basin. They have allowed us to analyze shortwave and long-wave radiation, meteorological data, and other relevant parameters. These data products have significantly contributed to our understanding of disruptions in the energy budget and the implications for hydrology, climate change, and engineering practices in the basin. It has also enabled the development of empirical relationships to estimate surface fluxes and highlight the degradation of the water budget, thus aiding in the identification of potential climate change effects resulting from human activities. In summary, these products have played a pivotal role in our research mission by providing the necessary data and insights to assess and address critical environmental changes in the Nzoia River Basin. And as an additional comment, I'll say that you can really observe the changes in the energy budget according to the activities changing in the basin. For instance, I can see the National Environment and Management Agency was established around 1990 something. And if you look at the energy budget, you can see changes in surface albedo and shortwave upward irradiance to reflect that. And for those of you who know Wangari Maathai and our work in conserving forests in Kenya, if you observe the basic, you see the same changes. So with that, I think I'll end the slideshow. And you can contact me for any further clarifications. Thank you.
Thank you for that great presentation.